Hello everyone. Welcome to this video on Python functional programming. Today we're going to dive into the world of functional programming in Python, specifically focusing on higher-order functions and pure functions. Functional programming is a programming paradigm that emphasizes the use of functions. Instead of focusing on changing the state of a program, we treat computation as the evaluation of mathematical functions. In functional programming, we avoid changing state and mutable data. We emphasize expressions over statements. Here is a simple example. In an imperative approach, to get squares of a list of numbers, we first create a list of numbers. Then we create another empty list named squared. After that, using a for loop, we iterate over each number in the numbers list and append its square to the squared list. On the other hand, using the functional approach, we can achieve the same result in one line of code using the map function. We apply a lambda function to each element of the numbers list. Lambda function takes a number x as input and returns its square. Finally, to print the result, we convert the map object into a list. Let's start by understanding higher-order functions. So, what are higher-order functions? Higher-order functions are functions that can do one or both of the following: take one or more functions as arguments or return a function as a result. Python has several common higher-order functions, such as map, filter, and reduce. Sorted is also a higher-order function, especially when used with a key function. Even decorators are higher-order functions. Here is a simple example of a function that takes another function as an argument. Let's define a function named apply_twice, which takes a function func and a value as input. It applies the function func twice to the given value and returns the result. Now let's use this higher-order function. We define another function add_5, which simply adds 5 to its input. We can use apply_twice with add_5 to add 5 to a number, and then add 5 again. For example, apply_twice, add_5, 10, will return 20. Now let's explore some common higher-order functions in Python with examples. The first one is map. The map function applies a given function to each item in an iterable, such as a list. The code shows an example where we square each number in the numbers list using a lambda function. Next is the filter function. The filter function filters items from an iterable based on a function that tests each element. This example filters out the even numbers from the numbers list using a lambda function that checks if a number is even. Reduce is a function that applies a function cumulatively to the items of an iterable, reducing it to a single value. This example shows how to calculate the sum of all numbers in a list using reduce. Note that reduce needs to be imported from the functools module. Lastly, sorted with a key. The sorted function can take a key argument, which is a function that is called on each list element prior to making comparisons. This example sorts a list of words by their length using a lambda function as the key. Now let's talk about pure functions. So, what are pure functions? A function is considered pure when it adheres to the following rules. Given the same input, it always returns the same output. It has no side effects, meaning it doesn't modify any external state. It doesn't depend on any external state. There are several benefits to using pure functions. They are easier to test and debug. Pure functions can be safely cached or memoized to improve performance. They are naturally thread-safe, making them suitable for concurrent programming. Pure functions are easier to reason about, making code more predictable. Let's look at an example to differentiate between pure and impure functions. Here we have an impure function add_to_total that modifies a global variable total. This function has side effects because it changes the value of a variable outside its scope. On the other hand, we have a pure function add that simply adds two numbers together. This function has no side effects and always returns the same result for the same inputs. Now let's put it all together with a real-world example. Here is an example of a data processing pipeline using functional programming concepts. In this example, the process_data function takes a list of data, filters out invalid entries using filter, transforms the data using map, and calculates the sum of the transformed data using sum. Each step is performed using pure functions, ensuring that the data processing is predictable and free from side effects. Another very important concept is function composition. Function composition is the combination of two or more functions to produce a new function. The compose function takes two functions f and g as input and returns a new function that applies f after g. For example, let's define two simple functions, double and increment. Double function multiplies its input by 2, and increment function adds 1 to its input. We can use the compose function to create a new function double_then_increment, which first doubles its input and then increments it by 1. If we pass 5 to this compose function, it will first double it to 10 and then increment it by 1, resulting in 11. In summary, functional programming in Python offers cleaner, more maintainable code through higher-order functions and pure functions. It enables concise data transformations, improved testability, and more predictable behavior. Now let's explore some advanced functional techniques in Python. Beyond the basics, there are several other techniques you can use to enhance your functional programming skills. These include partial functions using functools.partial. Decorators can also be used as higher-order functions. Recursion can be used instead of loops. You can make use of list and dictionary comprehensions. Use of immutable data structures will also enhance functional programming skills. Also, function caching with ru_cache will be helpful. Here are some examples. Partial functions allow you to create new functions from existing ones by pre-filling some of the arguments. In this example, we create a double function from the multiply function by pre-filling the first argument with 2. Now calling double with 5 will return 10. Decorators are a powerful feature in Python that allows you to modify the behavior of functions in a clean and reusable way. In this example, we define a logger decorator that prints a message before calling the decorated function. This can be useful for debugging and logging. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.